Pre-calculus review, part 2. In this video, we are going to review some trigonometry knowledge that we would need for our calculus. So let's look at number 12. Definitions of sine, cosine, tangent, secant, cosecant, cotangent. Let P be the point on the terminal side of angle theta in standard position. And you know the standard position is the position such that initial side is the positive x-axis and turn the angle to the counterclockwise. Let P be x, y point such that it is on the terminal side. Then we can find the radius r by using Pythagorean theorem, square root of x squared plus y squared. And those x squared and y squared are from the point P, x, y. And because you are squaring x and you are squaring the y and adding two positive numbers, you can see that r is going to be always positive. And then, as you recall, sine theta is defined by y over r. Cosine theta is x over r. Tangent theta is sine over cosine, so you will get y over x. And cotangent theta is 1 over tangent theta, so all you have to do is flip over the tangent, so you get x over y. Secant theta is 1 over cosine theta. So you can flip over the cosine theta, so you get r over x. Cosecant theta is 1 over sine. So you are going to get the reciprocal of sine theta, which is equal to r over y. So now let's do a problem. Example. Theta is in standard position and its terminal side is defined by the equation x minus 2y equals 0, where x is less than or equal to 0. Make a sketch indicating theta and find cosine theta, tangent theta, and cosecant theta. So you can see that this part where x minus 2y equals 0, which is the equation of a line, with restriction that x is less than or equal to 0, then we're only going to get a ray instead of a line, right? Because we're going to only take the part where x is less than or equal to 0. So then let's go ahead and solve this equation for y so we can sketch the graph. And we will have negative 2y equal to negative x. And divide both sides by negative 2. I will get y is equal 1/2 x. So this is a line passed through 0, 0. So one of the points is x is less than or equal to 0. I can choose x equals 0. And when x is 0, y is 0. So let's come up with one more point such that x is less than or equal to 0. And when we plug it in here, it would give you the nice number. What x should we choose? Yes, I would definitely choose multiples of 2 that is negative. So negative 2 sounds really good to me. So when you plug that number here, I get y is equal 1/2 times negative 2, and 2's cancel. I get y equal negative 1. So here is the 2 point. I do have 0, 0, and negative 2, negative 1, and I will get a ray passing through 0, 0, and negative 2, negative 1. So then I can now find the r, and r is going to be equal to square root of x squared plus y squared, and our x is negative 2, our y is negative 1, so you get negative 2 squared plus negative 1 squared, which will give me 4 plus 1. So I get square root of 5 as my r. So now I can find my cosine theta is equal to x over r, and x is negative 2, and r is radical 5. But we would not like to have a radical in the denominator, So simplify, it is going to be equal to negative 2 over radical 5. We multiply by radical 5 over radical 5. So you will get negative 2 radical 5 over 5. Cosine theta is negative 2 radical 5 over 5. Now, I can find tangent theta. And tangent theta is equal to y over x. And that is equal to negative 1 over negative 2, which would give me 1/2. So I found the tangent theta. Lastly, I need cosecant theta. And cosecant theta is equal to r over y. So I will get radical 5 over, our y is negative 1. So you will get negative radical 5 as your cosecant theta. Next, number 13, find trig function values of quadrantal and special angles. And here is unit circle, which is a circle of radius 1. And therefore, cosine theta equal x over r. And since r is 1, we have x equal cosine theta. And y over r is sine theta. And since our r is 1, you get y equal sine theta. All right, and I used to tell my students signs of 3 trigonometric functions on each quadrant. I used to say all students take calculus. So then all means all 3 sine and cosine tangent functions are positive in quadrant 1, and student. So in quadrant 2, only sine is positive. And then on third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. And here are special angles that you need to memorize. And for all these special angle of 30 degree, 45 degree, 60 degree in radians, pi over 6, pi over 4, pi over 3, and their reference angles, we can memorize these values for trig functions and use it. This is how I used to memorize when I was a student. For sine theta and cosine theta, all denominator is 2, but sine numerators increase. So for 30 degree, it's a square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. So denominator is 2, 2, 2, and then numerators are square root of 1, square root of 2, square root of 3. And I just memorized that and say cosine is backwards. It's a radical 3 over 2, radical 2 over 2, radical 1 over 2, because radical 1 is just 1. But that way it's easier to memorize. And also the reason is because the sine function and cosine functions are cofunctions each other. So for any angle theta, sine theta is equal to cosine of 90 minus theta. Remember this? And for any angle theta, cosine of theta is also sine of 90 degree minus the theta. That's why sine 30 is equal to cosine of 60, and sine 45 is equal to cosine of 45, and sine 60 is equal to cosine of 30. Okay, and then for tangent theta, instead of radical 3 over 3, it's the smallest value, which is 1 over radical 3, and then 1. And square root of 3 is bigger than square root of 1, so value increase, but those radicals are both has to do with the radical 3. So this is how I used to memorize the values. All right, so let's do an example. Give the exact value of each. Cosine of pi. Pi is right here. So cosine of pi, well, cosine is the x value. So cosine of pi is right there, which is negative 1. Tangent 3 pi over 2, well, tangent is y over x. And 3 pi over 2 is right here. Y is negative 1 over x is 0. So therefore, undefined. Cosecant pi over 6 is equal to 1 over sine pi over 6, and sine of pi over 6 is equal to 1/2, which is equal to 1 times reciprocal of 1/2, which is 2. So I get value 2. Reference angle. Reference angle is theta r, which is equal to acute angle formed between the terminal side of theta and the nearest x-axis. So using reference angle, let's go ahead and find the cosine of 7 pi over 6. Okay, so 7 pi over 6 is 210 degree. So acute angle formed by terminal side of angle theta and the nearest x-axis is right here. And reference angle in third quadrant can be found by theta minus pi. And since our theta is 7 pi over 6 minus pi is pi over 1, so you multiply by 6 over 6, you get 6 pi over 6, so you get pi over 6. So that's our theta r. And in third quadrant, you can see that cosine is negative. So this is negative, and cosine of reference angle, which is pi over 6. And cosine of pi over 6 is radical 3 over 2. So this is negative radical 3 over 2. Now, let's find the tangent 3 pi over 4. 3 pi over 4 is an angle in quadrant 2. And to find the theta r in second quadrant, you do pi minus the theta, and our theta is right now 3 pi over 4. So you do pi minus 3 pi over 4, and pi is 4 pi over 4 by multiplying 4 over 4. So you get 4 pi over 4 minus 3 pi over 4, which is pi over 4. So your theta r, reference angle, is pi over 4. So now you can find the tangent 3 pi over 4. Theta is in quadrant 2. So tangent theta is negative there since the only sine function is positive there. So the tangent 3 pi over 4 will be negative, and we can use tangent of reference angle we found is pi over 4, and tangent pi over 4 is 1. So tangent 3 pi over 4 is negative 1. Number 14. Graphs of the trig functions. You must remember the characteristics of 6 trigonometric functions and their graphs. So let's review. We're going to study one cycle of each graph. And you got to remember 5 key values. It's really helpful. So here's the y equals sine x. And 5 key points of sine x is 0, 0, and the maximum pi over 2 comma 1, go back to pi comma 0, and minimum 3 pi over 2 comma negative 1, and back to 2 pi comma 0. So these are 5 key values. One period, as you see, is 2 pi. The roots are, you can see 0 comma 0, pi comma 0, 2 pi comma 0. So you have a 0 and pi and 2 pi. Next one's going to be 3 pi. Next one's going to be 4 pi, so on. So you can see that roots are x equal n pi, where n is element of integers. Domain is all real numbers, since this graph is continuous on all real numbers. So domain is negative infinity to infinity. Range is, this sine graph goes up and down from negative 1 to 1 and take all values in between. So range would be bracket negative 1 to 1. So that's what range is going to be. Okay, now y equal cosine of x, and cosine of x, this time start from 0, 1. That's the starting point, and go to pi over 2, 0, and then hit the minimum pi, -1, and go back up 3 pi over 2, 0, and back to 2 pi, 1. So these are 5 key values of cosine of x. Period is 2 pi, like sine of x. What are your roots? Roots are, first roots you see is pi over 2. And the next one is pi later. You get 3 pi over 2. Next one's gonna be another pi later. So we say all the roots are x equal pi over 2 plus n pi, where n is element of integers. So these are roots of cosine x. Again, cosine function is also continuous function on all real numbers. Domain is -infinity to +infinity. The y values goes up and down from -1 to +1 inclusive. So range is bracket -1 to 1 bracket. Next, let's take a look at y equal tangent x graph. Unlike sine graph and cosine graph, tangent graph have a period of pi. So one whole cycle of tangent x goes from -pi over 2 to pi over 2. And 5 key values includes 2 asymptotes. So it is not value that's on your graph. And you have first vertical asymptote, which is x equal -pi over 2. And then you have a key value, -pi over 4, -1. And you have a 0, 0. You have a pi over 4, +1. And you get another key value as a vertical asymptote, x equal pi over 2. And you get vertical asymptotes starting at pi over 2 plus n pi, where n is element of integers. So then domain is, since your graph is discontinuous at all these x values such that you have a vertical asymptotes, so domain will be x not equal to those points of a vertical asymptotes, which is pi over 2 plus n pi, where n is element of integers. And range, as you see, graph of tangent goes from -infinity to +infinity. So range will be -infinity to +infinity. All right, y equal cotangent of x also have a period pi, and you can see that whole graph can be drawn from 0 to pi, where x equals 0 as one of your vertical asymptote, x equal pi as another vertical asymptote. So key points are one of the vertical asymptote, pi over 4, 1, pi over 2, 0, 3 pi over 4, -1, and your vertical asymptote x equal pi. And period is pi. Vertical asymptote occurs x equal at 0, pi, 2 pi, 3 pi, so on. So x equal n pi, where n is the element of integers. So therefore domain is all real numbers except those x such that you have a vertical asymptote there. So x cannot be equal to n pi then, where n is element of integer. The y values of your graph goes up all the way to +infinity to the left. It goes all the way to -infinity to right. So you get range -infinity to +infinity. Okay, last two graphs, y equal cosecant x and y equal secant x. So let's first look at y equal cosecant x. Cosecant x is equal to 1 over sine x. And you know sine x graph goes from 0, 0, maximum pi over 2, 1, back to pi, 0. minimum 3 pi over 2 comma negative 1 back to 2 pi comma 0, and graph goes like this. And your y equal cosecant x is graph above maximum and graph below minimum. And since sine x is in the denominator, every time sine x is 0, we will get 1 over 0, which is undefined. That's where you're going to have vertical asymptotes. And you know sine x is 0 when x is equal 0. So your first vertical asymptote is x equals 0. The next one, next to sine x is 0 when x equal pi. So your second vertical asymptote of cosecant x is x equal pi. And the next sine x is 0 again at x equal 2 pi. So you get another vertical asymptote at x equal 2 pi. So then 5 key values of y equal cosecant x is first vertical asymptote, x equals 0. And then relative minimum, pi over 2 comma 1. Another vertical asymptote, x equal pi. Relative maximum, 3 pi over 2 comma negative 1. And last vertical asymptote, x equal to pi. So you can see again, period is 2 pi. And you can see one whole cycle of y equal cosecant x goes from 0 to 2 pi. And vertical asymptote occurs at 0, pi, 2 pi, therefore x equal n pi. So then domain of y equal cosecant x is x not equal to n pi, where n is element of integers. How about range? You can see this graph is cut off, right? It's a two pieces. And if you look at the first one goes from 1 to up, 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 up. It goes all the way to infinity. And if you look at the second piece, the maximum value is negative 1, and it goes down, 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 down. So it goes all the way down to negative infinity. So range is parenthesis negative infinity to negative 1 bracket, since it is included. Union, second piece starts from positive 1 to positive infinity. So that's going to be the range. Now, y equals secant x is a little bit tricky because it starts rather kind of odd point. We needed to start at negative pi over 2 so that we can see the whole graph. If we start from 0, I'm going to get this piece right here and this one, and then I'm going to get only half of this graph like this over here. So that won't be too nice. So to look at two pieces just like cosecant graph, we can define y equals secant x as a one whole cycle from negative pi over 2 to 3 pi over 2. So again, period is 2 pi, and vertical asymptote will occur since y equal secant x is 1 over cosine x. You will have a vertical asymptotes every time cosine x is 0. And as you know, cosine starts from the maximum value of cosine 0, 1, and then it's 0 at pi over 2, and it is minimum negative 1 at pi, and then it is 0 again. So this it was a y equal cosine graph. It actually goes more up to here. But anyway, if I continue to the left from x equal 0, 1, graph will be going down like that. So this is where cosine x is also 0. That's why you have a vertical asymptote there. So then your 5 key value is forced asymptote x equal negative pi over 2, and you have relative minimum at 0, 1, and you have a second vertical asymptote x equal pi over 2, and your relative maximum at pi, -1, and your last key value is another vertical asymptote, which is 3 pi over 2. So you can see the first non-negative vertical asymptote is x equal pi over 2. So we say vertical asymptote occurs at x equal pi over 2 plus n pi where n is the element of integer. So therefore domain will be x not equal to those values of vertical asymptotes, which is pi over 2 plus n pi, where n is the element of integer. And just like y equal cosecant x, the y values of secant graph also, you can see from first part, from 1, and it goes up, 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 up. So it goes to infinity, and you don't have any y value in between -1 and 1. And from negative infinity goes all the way up to -1. So it has two pieces. So range is negative infinity, comma, -1, bracket, union, bracket, 1 to positive infinity. Now let's do some hands-on examples. Sketch one cycle of the graph of y equal 1/2 times cosecant quantity x minus pi over 4 using transformations. All right, so recall, what is this 1/2 multiplied in front of your function? That will be vertical stretch or compression. And since this number is less than 1, it's gonna give you vertical compression. All right, now we also have x minus pi over 4, and that would be, yes, horizontal shift. Is it to right or left? To right, pi over 4 unit. Okay, so then for all x comma y that were on y equal cosecant x, we'll move to x goes to x plus pi over 4 unit to the right. So you add pi over 4. And y, all this number that is multiplied in front of a function, that will be multiplied to y. So y is going to go to 1/2 y. And remember those 5 key points that we just went over, y equal cosecant x. The first one was vertical asymptote x equals 0. Second key point was it was a relative minimum at pi over 2, and the minimum was 1. Second vertical asymptote was x equal pi. And then third key point was 3 pi over 2, comma, -1. And last vertical asymptote was x equal 2 pi. So all these points, x will move to x plus pi over 4, y will go to half y. So first vertical asymptote will go to x equal pi over 4, since 0 plus pi over 4 is pi over 4. And the second point, pi over 2 plus pi over 4, we're going to multiply first fraction by 2 over 2. So you get 2 pi over 4 plus pi over 4, which is 3 pi over 4. So this point will go to 3 pi over 4, comma, 1 times half is half. Now x equal pi plus pi over 4 is equal to, since pi is pi over 1, you multiply 4 over 4. So now you have 5 pi over 4. So next to vertical asymptote is x equal 5 pi over 4. Now 3 pi over 2 plus pi over 4 is, you multiply 2 over 2, that's a 6 pi over 4 plus pi over 4, which is 7 pi over 4. So this point will go to 7 pi over 4, comma, -1 times half is -half. And now for x equal 2 pi plus pi over 4. 2 pi is 2 pi over 1. So multiply by 4 over 4, I get 8 pi over 4 plus pi over 4, which is 9 pi over 4. So my last vertical asymptote is x equal 9 pi over 4. So let's now graph this. Let's say one grid is pi over 4. Then next one is 2 pi over 4. Next one is 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. 9 pi over 4. And my three asymptotes are x equal pi over 4. My second asymptote is at x equal 5 pi over 4. My third asymptote is x equal 9 pi over 4. So here are my three vertical asymptotes. And now my second key point is 3 pi over 4 comma 1 half. 1 is being on there. This is 1 half and this is negative 1 half. So we have a 3 pi over 4 comma 1 half. That's a relative minimum. And fourth key point is 7 pi over 4 comma negative 1 half, which is right here. And here is relative maximum. So now you try to graph a shape like almost a parabola. And here is my graph. We're done. Next example. Find the formula for the vertical asymptotes. Use it to find three vertical asymptotes of y equals 4 times tangent quantity 3 over 2x plus pi over 4 minus 5. Alright, so to find the new formula to find the vertical asymptotes after the transformation, what you do is you set argument equals the normal vertical asymptote formula. What do you mean? So here, your argument is 3 over 2x plus pi over 4. So you're gonna set 3 over 2x plus pi over 4 equal to, what is the normal vertical asymptote formula for tangent? For tangent, recall, vertical asymptotes can be found by the formula pi over 2 plus n pi. Now you solve for x, and that will give you the new formula for finding vertical asymptotes after the transformation. So to solve this, we're going to subtract pi over 4 both sides. Then I have 3 over 2x only, since this is gone. And since I can multiply here by 2 over 2, I get 2 pi over 4 minus the pi over 4. So you get pi over 4, bring down the n pi. Let's combine these two to make a single fraction so that it's easier to calculate and have a better looking formula as well. So then I'm going to make n pi as a n pi over 1 and multiply 4 over 4. So then my right hand side become pi plus 4 pi n over 4. And now to solve for x, I need to get rid of 3 half that is multiplied to x. So we are going to multiply both sides by reciprocal of 3 over 2, which is 2/3. So then it get all cross cancel. 2 goes there once, 2 goes there twice. So my new formula is x equal pi plus 4 pi n over 2 times 3, which is 6. So I found the new formula for my equation given. Now, it also says to find the three vertical asymptotes using this. And you know here, n is for any integers, right? For n element of integers. So you can pick out any three integers to find out 3. So I'm gonna start by n equals 0. So for n equals 0, I'm gonna get x equal If n is 0, you don't have a 4 pi n, so you get pi over 6. And if n equal 1, let's do it mentally. If n is 1, 4 pi times 1 is 4 pi. 4 pi plus pi is 5 pi. So you get 5 pi over 6. N equal 2, you will get x equals 2 times 4 pi is 8 pi. 8 pi plus pi is 9 pi over 6. But then this one reduce, right? So let's reduce. 3 goes there twice. 3 goes there 3 times. So it is 3 pi over 2. So therefore, 3 VAs that they want me to find are x equal pi over 6, x equal 5 pi over 6, and x equal 3 pi over 2. So I found my 3 VAs as well. Next example, solving trig equations. Solve on the interval 0 to 2 pi equation 2 times cosine square x minus cosine x minus 1 equals 0. How do you solve such an equation? Yes, you factor. All right, since my first term is 2 cosine square x, you can look at that as product of 2 cosine x times cosine x. That would give you 2 cosine square x. And how about last term? This is the product of last and last. So your last number has to be one number positive 1 and one number has to be negative 1. Then let's put 1 and 1 for now to figure it out which one should be positive 1 and which one should be negative 1. As you know, your middle term is negative cosine x, and that must be the sum of the outer two and inner two. So here is our outer two. Outer two is 2 cosine x. Inner two will be 1 cosine x. In order for you to obtain negative cosine x, 2 cosine x must be negative and cosine x must be positive, so that you get negative 2 cosine x plus cosine x, which when you combine gives you negative cosine x. So that should be the sign, which is equal to 0. Then now, using zero product property, what is that? Zero product property says, from your algebra, if A times B equals 0, then either A must be 0 or B must be 0. That's what the zero product property says. So once you factor, you know one of these quantity has to be 0. So let's set 2 cosine x plus 1 must be 0, or cosine x minus 1 must be 0. From the first one, then 2 cosine x has to be negative 1, or cosine x must be 1. Then cosine x must be negative 1/2, or cosine x must be 1. All right, so now knowing all students take calculus, we know cosine x is negative on second and third quadrant, and reference angle theta r for 1/2 is pi over 3. And to obtain this angle x, you do pi minus pi over 3. So you get 2 pi over 3. And to obtain this x, that's a pi plus pi over 3. So you get 4 pi over 3. And to have cosine x equal 1, you know x must be 0, since the cosine 0 is 1. And then next time when cosine x is 0 is at 2 pi. But you can see 2 pi is not included in the domain. So you found all three solutions, and your solutions are 0, 2 pi over 3, and 4 pi over 3. Number 16, trigonometric identities. Remember you learned all these identities? You are going to use most of these. So make sure you memorize all the way up to here. When? Today. It will pop out everywhere all the time from the chapter 1. So you must memorize everything up to this point. And I don't really remember using half angle identities. So when it's a time that we need them, I will let you know. But for now, I really need you to memorize from here to here. Okay? So make sure you memorize all of these formulas today. So you have it with you already. Okay? Okay, you memorized all the formulas now, right? So let's assume you did and do the following problems. Simplify each trig expression. Quantity sine of negative t plus cosine of negative t, quantity square. Well, sine is odd function. So sine of negative t is equal to negative sine t. And cosine is even function. So cosine of negative t is just equal to cosine t. So let's rewrite this. This is then equal to negative sine t plus cosine t quantity square. Now we have to use algebra. What was any binomial square? It was a square plus 2ab plus b square. Very good. So let's apply that to negative sine t and cosine t. So we are going to apply, and it is negative sine t square plus 2 times negative sine t cosine t plus cosine t square is the same as cosine square t, which is equal to then negative sine t. When you square it, negative multiplied twice, so you get positive sine square t, and plus 2 times negative sine t times cosine t gives you negative 2 sine t cosine t plus cosine square t. And as you can see, sine square t plus cosine square t, they add them up to 1. So we can rewrite this as 1 minus 2 sine t cosine t. But then remember double angle formula? 2 sine t cosine t was equal to, yes, sine of 2t. So finally, we can write that as 1 minus sine of 2t. All right, next problem. Can you simplify cosine of pi over 2 plus theta? Then now you gotta use cosine of a plus b formula. Cosine of a plus b was cosine a times cosine b minus sine a times sine b. Very good. So let's do that one now. This is equal to cosine of pi over 2 cosine of theta minus sine of pi over 2 times sine of theta. Then that's equal to, what's the cosine of pi over 2? 0 times cosine theta minus, what's sine of pi over 2? 1. That's right, times sine theta. Now 0 times cosine theta is 0, so you get negative sine theta. And that's the answer. Number 17, right triangle trigonometry. So when you have a right triangle, we could use SOHCAHTOA. You guys have that phrase before, right? SOHCAHTOA. So what it means is sine of theta is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Yes, so we're going to use the SOHCAHTOA to answer the next question. Find the value of x. This is the angle theta, and adjacent is the leg that is adjacent to that angle. So adjacent will be this side. Well, how do you know it's not this? Well, that's adjacent, but since it's where right angle is looking at, it is actually the longest side, and it is hypotenuse. So then that makes the other side opposite. However, right now, what you have is adjacent, and what you need to solve for is the x. So you need SOHCAHTOA such that you use adjacent and hypotenuse. So what would that be? Yes, ka use adjacent over hypotenuse. So you're going to use cosine. So therefore, you can say that cosine of 30 degree is equal to adjacent 18 over hypotenuse, which is x. Yeah? And then what's cosine of 30 degree? Cosine of 30 degree is radical 3 over 2, which is equal to 18 over x. Now you can cross multiply and set them equal. So you get radical 3x equal 36 divided by radical 3 divided by radical 3. I'm going to rationalize this answer. So I'm going to multiply by radical 3 over radical 3. So then that's going to give me x is equal 36 radical 3 over 3. 3 goes there once, 3 goes there 12. So my x is 12 radical 3. Last one, guys. Number 18. Inverse trig functions. So here are 6 inverse trig functions and their ranges. So hardest part is memorizing each ranges, right? So here you can see inverse sine, inverse tangent, and inverse cosecant. The range is negative pi over 2 to pi over 2. Only difference is for sine inverse, negative pi over 2 to pi over 2, and the points are included, and there's no value in between that we're excluding. And for the tangent inverse, it is negative pi over 2 to pi over 2, but end points not included. For inverse cosecant, we are excluding 0. That is in the middle of negative pi over 2 to pi over 2. Okay? And then for the inverse cosine and inverse cotangent and inverse secant, the range is 0 to pi. And again, difference is for inverse cotangent, we don't include endpoints 0 and pi. And for inverse secant, since 0 to pi, the midpoint is pi over 2, we exclude the pi over 2 there. So that way, if you make 2 groups, then it's a little bit easier to memorize. Okay, so let's do these 6 problems. I have an input for all negative numbers for all of them. So it is a matter of finding the right quadrant. Okay, so sine inverse of negative number will be negative angle in quadrant 4. And what you have to think is sine of what angle is equal to negative radical 2 over 2. And yes, I want that angle to be in negative pi over 2 to pi over 2. But because it is negative, it's going to be angle from negative pi over 2 to 0. And I know sine of pi over 4 is radical 2 over 2. So this must be negative pi over 4. Next problem. What's inverse cosine of negative radical 3 over 2? Now again, I could think instead cosine of what angle is negative radical 3 over 2. And here, my angle must be in 0 to pi. I know cosine of pi over 6 is radical 3 over 2. So I need to find angle in second quadrant since I have an input negative number. So that angle must be pi minus pi over 6, which is 5 pi over 6. Okay. Tangent inverse of negative 1 equal what angle? Again, that means tangent of what angle is equal to negative 1. And again, inverse tangent, the range is negative pi over 2 to pi over 2. And since the tangent of pi over 4 is 1, this must be negative pi over 4. Inverse cotangent of negative 1 equal what angle? That's the same thing as answering cotangent of what angle is equal to negative 1. And my angle must be found from 0 to pi, and the point not included. Now, cotangent theta is 1 over tangent theta, which is equal negative 1. Negative 1 is negative 1 over 1. So when you cross multiply, it is tangent theta equal negative 1. Now, as you know, all students take calculus. Remember, I need to find the theta from 0 to pi because this is a cotangent theta problem, right? So now, unlike a problem before, even though tangent theta being negative 1, I need to find that angle from quadrant 2 because my answer can be only found from 0 to pi. And tangent is positive in the first quadrant and it is negative in the second quadrant. So therefore, my theta is going to be, and therefore, my theta is going to be pi minus pi over 4. So it will be 3 pi over 4. Next, inverse secant of negative 2 equal what angle? That is secant of what angle is equal to negative 2. And I need to find my angle from 0 to pi over 2 union pi over 2 to pi. And answering this again is the same as 1 over cosine theta equal negative 2, which is the same thing as cosine theta equal negative 1/2. And we know we have to find the answer from first and second quadrant. And cosine is negative in second quadrant. So my answer must be in second quadrant. And we know cosine of pi over 3 is 1/2. So theta in second quadrant can be found by pi minus pi over 3, which then gives me 2 pi over 3. Last problem. Inverse cosecant of negative 2 equal what angle? So then again, that is same thing as cosecant of what angle is equal to negative 2. And my answer, theta, needs to be found from negative pi over 2 to 0 union 0 to pi over 2. And cosecant theta is equal to 1 over sine theta equal negative 2. That is the same thing as sine theta equal negative 1/2. And we know sine of pi over 6 is 1/2. And now I need to find negative angle theta such that sine theta is negative 1/2. And sine of pi over 6 is 1/2. So therefore, sine of negative pi over 6 must be negative 1/2. So the answer is negative pi over 6. Alright guys, so we finished the trig review as well. And make sure you memorize all the formulas. And I'll meet you in calculus.